I'm the Executive Dean of the Faculty of Arts, and I'm delighted to open tonight's Sustainability Dialogue, Climate Security, a Local Perspective. I would like to begin the proceedings by acknowledging the traditional custodians of this land, our Darug partners. We extend our respects to the elders of the Darug nations, both past and present, and we also acknowledge any Indigenous guests present here this evening. I would like to welcome you all very warmly, academic colleagues, government, NGO, business, and community representatives. A special thank you to the Vice-Chancellor of Macquarie University, Professor Bruce Dalton, and to the Deputy Vice-Chancellor Research, Professor Saki Pretorius, for attending this event tonight. I would also like to welcome representatives from Ku-ring-gai Council. This event marks the commencement of a Memorandum of Understanding signed between Macquarie University and the Council in late 2014. For many years, Macquarie University and Ku-ring-gai Council have worked closely together. The MOU recognizes and builds upon this long-standing relationship. As articulated in the MOU, the organizations have agreed to work together in close partnership for the benefit of local communities and the environments. A very warm, particularly warm welcome to our panel of speakers tonight. The Honourable Rob Stokes, Member of Parliament, New South Wales Minister for Planning and Member for Pittwater, Professor Andy Pittman, Director of the ARC Centre of Excellence for Climate System Science at the University of New South Wales, Mr. Lachlan Feggins, National Manager, Environment, Fuji Xerox, and Dr. Jenny Scott, Sustainability Program Leader from Ku-ring-gai Council. And last but not least, of course, a very warm welcome to our students. Given the topic of tonight's dialogue, it is especially important that you are here tonight, as you are the decision makers of the future. The relevance and urgency for action on tonight's topic, climate security, is clear. Climate modelling for 2030 in the Sydney region predicts significantly increased spring and summer rainfall, while winter rainfall decreases. The prediction is for higher maximum temperatures, higher sea levels, changing flood patterns with greater runoff in summer and autumn. A longer fire season is predicted with an increased frequency of very high or extreme fire risk days. The risks emerging from these changed weather patterns feature more frequent and intense extreme weather events such as bushfires, storms, droughts, and heat waves. The predicted effects of climate change present an increasing threat to the lives of individuals and local communities, making us all more vulnerable to extreme weather. In light of this increased instability and insecurity, Macquarie Law School's Centre for Environmental Law, in partnership with Ku-ring-gai Council, are hosting this critical sustainability dialogue, which has brought together leaders in science, law, business, government, and communities to discuss climate security at the local level. I'm very much looking forward to an interesting discussion tonight, and I would now like to hand over to my colleague, Associate Professor Shoka Dalam, Director of the Centre for Environmental Law, to chair tonight's proceedings.
It is now my pleasure to begin by asking our first speaker up to discuss the science behind climate security. Professor Andy Pittman is a professor in climate science at the University of New South Wales. He is the new director of the ARC Centre of Excellence for Climate Systems Science. His expertise in climate modeling with broad interests extending across climate change, climate impacts, and land cover change. He has worked extensively on how land cover change and increasing greenhouse gases change the probability of extremes. He has been a lead author on the Intergovernmental Panel on Climate Change and on the Copenhagen Diagnosis. He's a member of the Advisory Board of Risk Frontiers, an industry-funded center that explores questions of climate change, volcanic, and hydrological risk for the insurance industry. He won the New South Wales Climate Scientist of the Year in 2010. He was appointed to the federal government's Science Advisory Panel to the Climate Commission in 2011. Ladies and gentlemen, if you could please welcome Professor Andy Pittman.
I'm going to give you a 10-minute or 11-minute summary of what the climate science tells us. Not easy to summarize a couple of dozens of years of research in 10 minutes, but I'm going to give it a go. So, first of all, The climate is warming. That's unequivocal. I hope we all accept that basic fact. It's based on observations by organisations around the world. It's also based on satellites. You can measure the warming of the temperature in the deep ocean, in the ice sheets, in the atmosphere, in fact, anywhere you choose to look. In fact, the warming of the climate system is now both unequivocal, and many of the changes we've observed are unprecedented. Global air temperature has increased by around 0.89 degrees since the start of the 20th century, and the warming trend is shown in that picture there. So the planet is getting warmer. It's getting warmer just about everywhere. Those of you with good sharp eyes will see a little blob of blue over the Gulf Stream of the North Atlantic. That's to do with the global ocean circulation response. It's not a good news story. It doesn't always rain, and it isn't always cold in the UK. But if you weaken the Gulf Stream, you can see cooling on a timescale of a decade of something like 10 degrees over Western Europe, and that isn't really a very good thing for us to be thinking about in terms of global security. If you look, the purpley colours there, I always need to remind people, that's not a bit of cooling, that's extra warming. So where you see the purples, that's more warming than where you see the reds. And generally the trend is now between about 1 and 2 degrees per decade. 0.1 or 0.2 degrees per decade. Natural forcing explains a small fraction of that warming. Most of the warming is due to human activity. Over the last period since about 1950, humans explain somewhere between 100% and about 30% of the warming, depending on the science and depending on how you slice and dice the cake, but it's somewhere between 30% and 100% of our fault. Sea level's going up. Even if you read The Australian, it's still going up. Global average sea level has risen by almost 0.2 metres over the 20th century. The recent trends are accelerating. Whether they're accelerating because of human activity or by natural variability isn't yet sure. So we're not sure the recent acceleration of sea level trends is due to humans. That rate of increase is unprecedented in at least the last 2,000 years. The upper trend on that diagram the last 30 years is satellites. It isn't because of the sampling of sea level rise by measurements at the surface of the ocean. Those measurements are consistent with what satellites tell us. So the Australian region is, as you may well have heard, particularly susceptible to extreme weather events and climate change. I'm going to touch very briefly on 4 examples: infrastructure and resilience, fire, sea level rise and issues around storm surge and the issues around a beach economy, and ageing population, because I'm getting a bit close for comfort to the end of the distribution that starts to get a little vulnerable to climate change. So, infrastructure. Here is the trend in the record hot days per decade in the graph on the left-hand side. And it's by decade, and you can look back to the 60s and the 70s and the 80s and the 90s and see there has been over a doubling in the number of extremely hot days over what we would have experienced in the 60s. So if people say to you it was hotter back then, that's a psychological response. In the same psychological responses I have, that when I was growing up in the UK, we always had a 2-week holiday and it never, ever rained. That is a statistical impossibility, but I have no memory of it ever raining when I was young. But it obviously did, and it wasn't hotter back when we were younger. The diagram on the right is a really nice one from Melbourne, where the train tracks buckled. That clickety-clack you hear on a train is the expansion slots in the rails to absorb an extremely hot day, because the steel expands and it expands to fill the expansion slot. And it doesn't take a lot of imagination to know what happens if the expansion slot isn't thick enough, wide enough. And the rails literally buckled. And that was 47 degrees in Melbourne. We are expecting it to be substantially warmer than that in the future. Fire. Top right picture of here was taken from Macquarie. It was taken from the top of E7B. And it was the fires, it would have been probably 10 years ago, 15 years ago. And that was lighting up the sky as the fires got to the edge of campus. So it isn't something that you would experience out in the Blue Mountains or just in Western Sydney or in rain. It actually got to the edge of this campus. And we are certainly expecting the weather conditions associated with fire to become significantly worse in the future. And if you actually look at the trends in fire weather, they are definitively getting worse. Heat waves kill people. 30,000 people were killed in a heat wave in 2003 in that developing part of the world called Europe. Climate change is not merely about the future, and you are not immune from it if you live in a rich Western country. So this summer was hotter than any in the previous 500 years. There was a 10 to 12 degree temperature anomaly. If you think of 47 degrees in Melbourne and add 12 degrees to it, which actually isn't going to happen, so don't stress, but if you add a few degrees on top of 47 degrees, you get prohibitively hot temperatures and it simply kills people. And it's getting worse in Australia. This is a paper from Sarah Perkins and Lisa Alexander in the Journal of Climate. I thought I should put some real science in here. It's very noisy because of variability. Global warming doesn't mean next year has to be hotter than this year, which has to be hotter than last year. It is the overall behavior of the system on longer timescales. And most of us, if we drew a line through that, would show the line grading upwards. Heat waves, this is the frequency of days, but if I look at the intensity of heat waves, the length of heat waves, the spatial distribution of heat waves, they're all deteriorating over the Australian continent, and we know why. So there's two things you can do if you want to know lots more about this. There's a program run by the New South Wales government called NARCLIM, and it's got a website like any good project has, but this one's actually really good because it's underpinned by some of the most innovative modelling that's ever been done, and probably the most innovative modelling that's been done for any state in Australia. And it provides you information tailored to New South Wales, and you can go and look up there about at reasonably fine resolution what will happen. It gives you maps like this showing increase in summer rainfall of 10 to 30%, decreases in winter rainfall over quite a lot of the Sydney Basin, increases in the frequency of days over 35, and a small increase in the risk of fire weather. But these still don't get to the nub of the problem. The nub of the problem are rare extremes occurring by definition infrequently, at times you don't want them to occur, often coincidental with other extremes occurring simultaneously. And that's where the cutting edge of the science is now. We're not there yet, but we are beginning to tease out how coincidental extremes break the adaptive capacity of a system. So the good news, because I keep being accused of only giving bad news, so I'm going to give you some good news. And the good news is the amount of warming is up to us. Not just us, but us as a species. If we cut emissions very deeply, ideally starting in about 1990, because that's when we started telling people we needed to cut emissions, we might keep global warming to the picture on the left, where over the continental surfaces warming is around 1.5 to 2 degrees. If we're a bit stupid and we don't seriously address the emissions problem at a global scale, we go to the picture on the right. And that shows continental warming in the mean of 5 to 7 degrees. Even that, on top of 47 degrees in Melbourne, is prohibitive. But we expect the extremes to warm by more than the averages. The bad news is, I think snowball and hell are the words I would use in the context of whether we will limit warming to 2 degrees. I think there's good evidence now that it's basically technically impossible. Emissions at the current trajectory are pointing us to warming of between 3 and 5 degrees, and I lack the confidence that that will be solved in Paris. But I would be very happy to be proven wrong. To make the 2 degree limit now means 3% per year, not per decade, 3% per year cut, and negative emissions from 2050. No one actually knows how to do negative emissions. We're currently emitting 10 billion tonnes of CO2 per year, And sometime in the next sort of 30 years, we're going to turn that 10 billion tonnes of emission to negative emissions where there's none being emitted and we're sucking it out of the atmosphere. Seems to me to be a courageous hope for the future. And so, I think the strategy that we need to be employing is a significant investment in building resilience, understanding our vulnerability, and planning for significant climate change as one of the key messages that come out of climate science over the last 10 years. If you want to know more, you can go to the the New South Wales website, climatechange.environment.newsouthwales.gov.au. They've really got to get that shorter, where there's a hell of a lot of really useful information. Or, nearer to home, Risk Frontiers, which was mentioned earlier, is a research centre which is the best centre in the country at understanding risk associated with natural hazards and natural perils. It's not very far from here, it's at Macquarie, and you're very lucky to have them. Thank you.
Our second speaker is Dr. Jenny Scott, who works at Kooringa Council as the Sustainability Program Leader. She has led the development of Council's position and strategy on climate change adaptation since 2008. Kooringa's climate change adaptation strategy has been adopted in China and Korea and by UN Economic and Social Commission for Asia and the Pacific for use in developing nations. Jenny is currently working with a leading NGO to introduce Kooringa's climate model into communities in northern Vietnam. Please welcome Jenny as she comes up to provide us with a localized example of addressing climate security. Jenny Scott.
Thank you very much. Just getting to my presentation. So we go from that global level and we're coming down to the local level. Kooringa is located just to the northeast of here, so we're a very close council to Macquarie University campus. But what we want to talk about is a culmination of a lot of the work that we've done with Macquarie academics over the last few years. And it's about capturing externalities and unintended consequences from bushfire risk management strategies in a changing climate. It's not only bushfire risk management strategies that we're concerned with, there are a range of others too, but the bushfire is probably the best example to show you. So as was said in Black Saturday in 2010, there are many links in the chain of preparedness for bushfire, and any one of them can break, leading to serious consequences. And for us that means you don't put all your eggs in one basket. So why is Kooringa so interested in bushfires? Well, the climate modelling, as Andy just pointed out, says we're going to have more days of extreme weather. Kooringa is one of the most vulnerable councils in New South Wales to bushfire because, as you can see by that red margin around the edge of the municipality, we have 14,000 houses on the bushland interface, and that's all high-risk bushfire area. It's mostly ridge-top development with older brick and tile homes, and those brick and tile homes are very susceptible to ember attack from bushfires. It's fire-prone vegetation. It's surrounded by 3 national parks plus 120 bushland reserves within the area itself. We have an ageing population, and as you can see by those areas hatched in blue, we have many problematic evacuation areas. Very hard to get in and out in times of a crisis. But Council also has many obligations around the bushland about how to manage it. We've got to protect habitats and look after threatened species. Invasive pest species need to be controlled, and high potential for erosion after bushfires means we have to put preventative strategies in place. But compounding all this complexity is an increasingly dense urban footprint, and that leads to increasing demand for recreation in these natural areas. And then there are issues of amenity, aesthetics, microclimate, just to name the few in a very long list. So what's Kooringa Council done? We needed to develop a way to prioritise adaptations in order to invest in those adaptations which were going to create the best result for the least amount of money. So we created a filter for all these adaptations that the experts in the community and council staff dreamed up. And we analysed them across the triple bottom line. And where they scored strongly negative, they got a -3, through to a sliding scale of +3 for those that were very beneficial. But it wasn't just the triple bottom line that we analysed it against. We also looked at risk abatement. And in this particular instance, it's risk abatement in terms of bushfire. So we looked at how would radiant heat be affected by that adaptation. Would it help suppress fire? Would ember attack be limited? Would the transference of fire deep into the urban area be limited as well? Firefighting capacity supported, or the general preparedness of the community? So those adaptations that scored over 12 were rated a high investment opportunity. Below 6, they didn't fall off the radar, but they're a lower priority. So the sorts of adaptations that scored very highly, where we believe the benefits exceeded the costs and therefore the externalities are largely accounted for, are things like installing fire-rated product around homes, making homes more resilient, increasing the number of homes that comply with the bushfire construction standard, and all the way through to just putting in simply fire danger signs. Those with a negative score, where the costs exceed the benefits and we think the externalities are largely unaccounted for, go through from compulsory high-risk property acquisition, where the cost is enormous. Right down, interestingly enough, the poorest score was increasing the number of prescribed burns. And the reason for this is that if you look across a triple bottom line, there's massive impacts in every category. It's expensive, it has social impacts, it has significant environmental impacts. And as a risk reduction measure, it only performs moderately. So what do? We go out and we do more research, and we worked with the RMIT and the Bushfire CRC, who had just finished some work on why bushfire survival plans in Black Saturday almost universally failed. Why was the reason? And they found that it was people are unable to think logically in a crisis. They underestimate the importance of their personal circumstances, their health, how resilient their houses are, and how this influences options when a major crisis occurs. They underestimate the importance of timely triggers, knowing when to decide to get out, and the need for writing plans for catastrophic conditions. And most people can't even imagine what a catastrophic condition is like, let alone plan for it. And dismiss the value of written plans, thinking, well, I've got it in my mind, that'll do. They also said, well, what people should do is understand the strengths and the weaknesses of their family and their house and their property, and understand the neighbourhood and how it might operate in a disaster context. They need to be prepared with practical alternatives as conditions change and change very quickly, and build and maintain local communication networks. So Council took all this information and packaged it up into the Climate Wise Community Project. So this project aims to strengthen community resilience, and by resilience we want people to become more self-reliant. We want them to take preventative action, empower them to make decisions in times of crisis with psychological preparedness. We want to use trans-dimensional mapping, and that's over the personal, the property and the neighbourhood dimensions. And we want it to be multi-hazard. We want them to understand that just because you invest in bushfire, that's not the end of the benefit. The benefit may also translate through to other extreme hazard, weather hazard types. So the Climate Wise Communities Project promotes the value of shared responsibility. It's not just the fireys' responsibility. It's not just councils. It's everybody's responsibility. To understand the roles and the limitations of the emergency services, that if a fire happens, a major fire happens, the chances of a fiery knocking on your door to help you evacuate is very remote. To be able to identify for themselves their personal property and neighbourhood levels of exposure, to identify the return on investment that they're going to get, not just from extreme weather events, but also maybe for extreme heat days. To strengthen the resilience of the homes to the multi-hazard and become aware of the need for flexibility and options no matter what the disaster type is that they face. And importantly, to complement the work that's already being done by our program partners. So just some of the tools that we use. We run a whole series of workshops, and this is continuing to roll out over the next few years. And one of the tools we use is to get people to map their home, to draw a sketch of their home, and they're in a workshop situation, and the bushfire people and the police and the SES are all there looking at their map saying what is a strength and what is a weakness. So it already gives them ideas about how they might strengthen their homes. We get them to think about their neighbourhood in the context of communication. Who are the people that they talk to regularly? Who can they rely on in the event of an emergency? And importantly, who might be relying on them? And then we do a what-if exercise. The RMIT bushfire team actually won an Australian Design Award for this particular exercise. And it's giving people a pack of cards, they take it home and they can test it against their own bushfire plan, that has a whole lot of contingencies that frequently pop up and make your bushfire survival plan fail. So your neighbour asks you for help, your car won't start, there's no water pressure in your house, a fallen tree blocks your driveway, and they discuss what they might be able to do in that eventuality. So what happens when externalities are not accounted for, where the costs exceed the benefits? We believe there are a few examples around bushfire, one being the 1050 vegetation clearing entitlement, another being to increase dependence on hazard reduction burning, putting all those eggs in one basket, and allowing more people to live in the bushfire hazard area just builds the scale of the problem. So in conclusion, we think fostering a shared responsibility approach appears the most efficient and effective way to build resilience. A diversity of approaches will strengthen resilience by toughening the built sector and reducing that dependence on controlling vegetation. We need to build climate change risk adaptations that are sustainable. And to be sustainable, they need to acknowledge and minimise the externalities, be equitable and affordable across the whole scale of the triple bottom line, build independence and enrich community cohesion and capacity for preparation and recovery from extreme weather events. Thank you.
So let's move on to our next speaker of this session, Mr. Lachlan Figgins, who has been working in the sustainability field since 2001. The last 7 years, Lachlan has been the environmental manager at Fuji Xerox Australia, a subsidiary of Fuji Xerox company headquartered in Japan. Lachlan's role translates the complexity of global environmental impacts into the day-to-day operations of the organization. This includes environmental compliance, environmental accounting, as well as developing a sustainability risk and resilience strategy for the Fuji Xerox global supply chain and identifying opportunities for sustainable products and services to meet customer needs. Lachlan has a Bachelor of Environmental Science from Macquarie University and is completing his Master of Sustainability at Sydney University. For his final master's project, Lachlan will be implementing a sustainable supply chain management program for Fuji Xerox Australia using a life cycle assessment methodology developed at Sydney University. Lachlan predicts this life cycle assessment approach will quickly and cost-effectively allows organizations with complex global supply chains to identify environmental and social hotspots in their supply chain. The Fuji Xerox hotspots include the carbon intensity of manufacturing of digital print devices and paper products. The hotspot results have enabled Fuji Xerox to make better decisions, such as targeting continuous improvement programs at high-risk areas. Lachlan lives in an off-grid property with his wife and 2 young children on 100 acres where he implements regenerative agriculture techniques and hopes to provide hungry customers with pasture-raised livestock and unique farm experience. To provide us with a business perspective of climate security, please welcome Lachlan Figgins.
So my name's Lachlan Figgins. I am the Environmental Manager at Fuji Xerox Australia. We're literally across the road from Macquarie University, so very close. And I'm here to give you a business perspective, which is a business perspective, not the business perspective of Fuji Xerox, in terms of how climate change, how we impact climate change and how we're going to deal with it at a local and a global level. So I'll give you a quick introduction of the business, then I'll talk about the risk profile and climate change, and this is essentially how the business factors in risk of unexpected events within the organisation. Then I'll get to the nub of it, what we do, what our impacts are as an organisation, where they occur, and of course, what we're going to do about it. and I'll wrap it up with a bit of a summary for you all. So, the introduction, Fuji Xerox has been in Australia for 50 years. We have been doing sustainability for a long time before it was called sustainability. Back in 1969, we developed the first print device capable of double-sided printing. We are global leaders in product stewardship. And if you don't know what that is, stay tuned, I'll tell you. We also invented remanufacturing, and I'll tell you about that a little bit later as well. Essentially, as an organisation, we have been doing sustainability for a long, long time. And all organisations have financial goals, and we need to make a profit to be a sustainable organisation. And for Fuji Xerox, our profit is to be $1 billion company. And to be $1 billion company, we need to grow that year on year. To make that financial capital a reality, we need to draw down what's called natural capital. Okay, so all the resources that are available to us in the earth, be they trees, fossil fuels, arable soil, whatever you might call it, we actually suck them in to our economy, at value add, and we push out products and services. And in doing so, we actually negatively impact externalities, which was raised by Jenny Scott. We negatively impact the areas that we extract those resources, and we also pollute, be they greenhouse gas emissions or solid waste. Well, what natural capital really is it's a global bank account of resources. And businesses essentially make withdrawals from natural capital on a constant basis without the actual consideration of having to make deposits. So that natural capital is continually being depleted. And in the context of tonight's discussion, we're talking about an ecological service, which is natural capital, and that is climate stability. And essentially, climate stability is something that we all enjoy. And as you saw from Andy Pittman's quick synopsis, it's not looking like a good picture unless we do something pretty quickly. The key thing about natural capital and the impacts is it's external to the formal economy. Nobody pays for it, okay? So it's up to organisations like Fuji Xerox to actually take a leadership position and actually factor into the decision making of the business. Now this is actually a Fuji Xerox risk profile at a local level, and I'm just going to focus on the top one here, which is an unexpected event or disaster. Now we've had some pretty severe local weather events here in Sydney recently. We have a location at Rose Hill, our eco-manufacturing centre, which was evacuated because of local flooding. Was there an impact on climate change there? Well, I'll let you be the judge of that. And we've already mentioned tonight the increasing incidence of heat waves. Now, in India right now, there's been 800 people confirmed dead by a heat wave. This is actually essentially where natural capital is feeding back into business and affecting financial capital. I know that heat waves in Australia are estimated to cost the Australian businesses $7 billion a year in lost productivity. So for us to reach that $1 billion financial target, we're going to actually have to factor this in because we're going to have productivity issues that we're going to have to deal with on an ongoing basis. We also have to look at our agility and efficiency of our supply chain. Now, the Japanese tsunami is just an example. It's not related to climate change, but it could very well be a climate change event that impacts our supply chain. We couldn't meet our customer demands. We didn't have products in the country because of this tsunami actually stopped our supply chain dead in its tracks. We need to factor those risks into our decision-making process, and it could very well be a climate-related disaster that impacts us next. And of course, sustainability. This is a key material issue for our stakeholders. Our stakeholders are our employees, our parent company, our local community. If we're not taking a leadership on sustainability, we're not doing a good enough job in their eyes. So, what we do printers, we do paper, we do digital documents. All these products and services have environmental impacts, and we use a tool, a scientific tool called a life cycle assessment, which actually helps determine where in the product life cycle the impact is at its most intensive. Now for the printing device, it's actually at the in-use phase. So that's when say printing devices or a fleet of printing devices are actually being used by customers over a 3 to 5 year time. The energy use and the carbon emissions associated with that is the most carbon intensive stage of that particular product's life cycle. So what do we need to do about it? We need to make it as efficient as possible. Paper. The most carbon intensive part of the paper life cycle is actually when people throw paper into the landfill. So it's 37% of the footprint of a paper product is actually embedded in how humans interact with that particular material, throwing it into landfill. Staggering. And from a digital perspective, the digital document, we maintain data centres. These are very, very energy intensive facilities, and we need to make sure that we're running those as efficiently as possible. Of course, to make these products and services, as I said, we need to draw down natural capital, be they minerals, be they forest resources, and we produce pollution, greenhouse gas emissions and waste. At the top here, you can see we have dependencies. At the bottom here, we have the impacts of the organisation. Now, we're talking about a local perspective here, but we are a global organisation, okay? So it doesn't make sense for us just to focus at the local level. But to deliver our products and services at the local level, we need buildings. We need people in the buildings. We need people to sell our products. We need back office staff to support sales. And of course, the administrative process. We need service techs to stop our machines from jamming in your offices. They need homes. You can start to see that this is actually getting a little bit more complex for a global organisation. What you see here, the buildings and the people, this actually accounts for around about 7,000 to 8,000 tonnes of carbon emissions per year. Remember that number. We're going to get a little bit more complex now. To get our machines to you, we need to drive them round. So there's a lot of logistics associated with what we do here in Australia. Before that, we need to bring them into the country. So there's shipping. If our forecasting is off, we have to fly them in. It's very costly and very carbon intensive to do that as an organisation. But the stage before that, we need to build the machines in the first place, manufacturing. And of course, we need resources to do that, and we produce pollution. As you can see, things are starting to go upstream and get more and more complex for a global organisation like Foodie Xerox. So let's look at this in its entirety. For us to deliver products and services to customers, we need people, we need buildings, we need logistics, we need manufacturing, we need natural resources. We pollute and we affect natural capital. So you can see here the full Foodie Xerox supply chain, and this is very, very simplified, mind you. This is actually about 80,000 tonnes of carbon emissions per year. So for Foodie Xerox to have a meaningful impact on the discussion tonight, climate security at a local level, we need to actually look at our entire value chain, because that's where our carbon is embedded. Our local network here with the buildings and people, that's about 10-12% of our total footprint. If we ignored the rest of our supply chain, we wouldn't really be doing a very good job. So we use life cycle assessment. We measured this across our entire supply chain. I can tell you not many organisations know what their total footprint is. What this told us was that our top 10 suppliers by expenditure were accounted for 55% of the annual expenditure, but 80% of the carbon emissions for the organisation. So for us to make the first step and direct our limited resources into actually reducing climate change, or reducing our impact on climate change and carbon emissions in our supply chain, we have to start with those top 10 suppliers. And this is a template that can be used for any organisation, any multinational organisation which imports products into Australia. So what do? As I mentioned before, we do product stewardship. We do it better than anyone else in Australia and arguably in the world. I can tell you that for a fact, because when a product that we make, we put a lot of energy, a lot of emissions are produced into making that. We deliver that to a customer, and then at the end of its life, we take it back. And we achieve 99.8 resource recovery. So all the energy embodied in those materials are continuously cycled through the materials economy. None of it goes to landfill. And we have third-party verification to prove that. Our paper products, for example. Now, everyone knows paper comes from trees. Increasingly, our paper is coming from paper. So we have 100% post-consumer recycled products that have sustainability certifications attached to them, and it actually turned out to be the most carbon-intensive part of our supply chain. So we made them carbon neutral. Of course, that doesn't wipe the slate clean. We are working towards actually making that product more carbon efficient. From a data centres perspective, very energy hungry. We just put them on 100% renewable energy. And of course, we're going to be working to lower the footprint of that data centre while that business increases. So to wrap it up, for Foodie Xerox Australia to have a meaningful response to climate security at a local level, we need to provide responsible products and services to our stakeholders here locally. We need to measure, analyse and understand and manage the emissions across our entire value chain, because it wouldn't make sense for us just to focus here in Australia when all our emissions are really embedded in our supply chain. Then we actually need to make people accountable and responsible within the organisation, and that is easier said than done, let me tell you. And a very important thing here, we need to have an iterative conversation with our stakeholders. We need to know what they think, what's important to them, and we need to respond in a meaningful way. And that is how Foodie Xerox, as a global organisation, will have a meaningful impact on climate security at the local level.
Now, our fourth speaker is Honourable Rob Stokes, is the Liberal member for Pittwater and the New South Wales Minister for Planning. Before entering to Parliament in 2007, Rob was a practicing solicitor and senior lecturer at the law school at Macquarie University. He holds a PhD in law, Master of Laws, Bachelor of Arts, graduate diploma in legal practice, and diploma in biblical studies. Rob has been actively involved in volunteer work in the legal profession and has written numerous articles on environmental planning and New South Wales tax law in a variety of books and academic journals. Outside work, Rob is an assessor and trainer with Surf Life Saving Northern Beaches and is a patrol captain in Monaville Beach, where he has patrolled over the past 20 years. Now tonight we will hear from Rob the legal and state government perspectives of the local response to climate security. Please welcome the Honourable Rob Stokes.
What we know, the background in relation to climate change and its impact in New South Wales, we've funded a study across New South Wales and the ACT called NARCLIM. It provides granular data about what the likely impacts of climate change are down to a 10-kilometre grid level. So it provides the data upon which local communities, and this is world-leading research, the data upon which local communities and local authorities can make decisions about what is likely to change based on current knowledge in relation to climate impacts over two horizons, to 2030 and to 2070. The headline is that across New South Wales, we're likely to see temperature increases of around 2.1 degrees by 2070. Now, that doesn't mean much in isolation. Where this comes into real operational assistance is at that granular level, because down to those 10-kilometre grid lots we can determine what local impacts are likely to be. But nevertheless, we know that the temperature is rising. We know that that is going to have an impact in relation to agriculture, in relation to bushfire planning, in relation to metropolitan coastal planning. We know that in terms of impacts in summer, for example, temperature rises are likely to be higher. We know that rainfall patterns are likely to be different, that at the moment we're likely to see wetter autumns and drier springs, which of course means that the bushfire season will become longer. We know also from work concomitantly being done within the Sydney Institute of Marine Science that sea temperatures off Sydney are likely to rise by a factor of about 3 degrees over the same period. And of course this brings with it a change in the nature or the dynamism of coastal processes. We know that there's likely to be changes in relation to swell direction, which means in itself that the impacts on headlands and on beaches, particularly the southern ends, as we get fewer systems from the south and more systems from the east in terms of east coast lows, and from the north, are likely to have different impacts on our beaches and our embayments. So we have a good and robust information base for the first time really to start making quite granular decisions at a local level about what we need to do to adapt our communities and make them more resilient to impacts of climate change. Now, resilience is a word that's now entered into the academic milieu in relation to these terms, but I'm referring to it in the original sense of C.S. Hollings when he was talking about ecological resilience, that is the ability of an ecosystem to recover from shocks to its pre-existing condition. Now, the challenge with that and the adaptive management that C.S. Hollings then went on to talk mainly about is it requires systems to be reasonably flexible and that not only flexible but able to change in new directions based on changing parameters around them. The difficulty in my world of metropolitan planning, which creates so much path dependency in relation to the development of communities, in relation to people's lives effectively. Once we make decisions in an urban planning context about where roads go, where railways go, where housing supply goes, that locks in patterns of development that shape how people's lives are shaped into the future. That is not a resilient process. In fact, cities by their very nature are quite rigid, quite brittle structures. You only need to think of what happens when a single train derailment happens and that causes chaos right across the system, or when there might be a wet weather event that causes traffic chaos or causes a sewage system to overload. The nature of urban systems are inherently brittle and inherently rigid. So what we know about a changing climate is we're going to need to become more flexible, yet the systems that we're developing are becoming more rigid. So we're forming, if you like, an exquisite tragedy that is a challenge that we have to solve together. And we know that this is a global challenge as well. We know that over the coming decades we're likely to see as much of 70% of humanity living in dense urban cores. In the case of Sydney, for example, we've just tripped over the 5 million mark, and by 2051 we're going to have 8 million people living in the greater metropolitan region. So the city currently, it comprises about 4,000 square kilometres, which is about the same size as Greater London. To put that into context, by 2051 we're going to have a similar population to Greater London as well. So these provide us with some big challenges in relation to planning for climate security effectively in the urban context. And we've got similar development pressures right along our coastline as well. Now, how do we deal with these challenges? I'm going to say a couple of controversial things before talking about what the government is doing. And these are a couple of controversial things because I think we all accept orthodoxies in planning, particularly about, it's funny, 100 years ago, urban planning as a profession was established under the motto of nothing gained through overcrowding, and the garden cities at the time were seen as the model to escape the overcrowded slums of central cities. And yet today, the orthodoxy is we need urban consolidation, we need urban renewal because land is at a premium, we need to be thrifty and efficient with the land resources we have. Now, I think that's right. I think obviously we need to be, but we also need to be careful in context of resilience, in context of a changing climate, to not lock ourselves into patterns of future settlement that create more headaches for us to resolve into the future. We already know that with higher density forms of development that they are more energy intensive. We know from work done within government and also externally, there's a lot of work going on by researchers under Stephen Hamnett, I think, at the University of South Australia, looking at the embodied energy and also the energy consumption of higher density forms of settlement. And the messages are that that actually some of the lower density forms can actually be more efficient if properly retrofitted. But with large tower blocks particularly, it's very difficult to get thermal efficiency. It's very difficult to get on-site energy generation. It's very difficult to store water effectively. It's very difficult to, in an energy efficient way, to get hot water up 30 or 40 floors. And in terms of a built form, and this is one of the problems I think with also our land tenure processes, we've at the time, Torrens title was a very efficient and expedient way in which to divide real property and assign ownership to it. It was flexible, it was resilient. There could be storms, there could be tempests, there could be bushfires, but at the end of the day, the land was still there, the parcel was still identifiable. When you put it in a high density context, that becomes more challenging because really in a high density context with the development of real property or of Torrens title in terms of strata title, real property is a parcel of air surrounded by carpet and paint and that exists only in that space in the sky. It's not a resilient form of development in that sense. With a parcel of land, for a farmer you can change your crop depending on what the weather conditions are. If it's a home on a block of land, you can change the design, you can add bedrooms, you can take them away. With a unit block, the urban form is predetermined and unchangeable. And of course, in 40, 50, 60 years' time, when some of the very large buildings that are being built at the moment start to deteriorate, what at present is an argument between maybe 6 or 12 owners of a strata block, at at the moment may well become an argument between 500 or 600 owners, many of whom are going to be located overseas, and when you're going to have real risks of bits of buildings falling off into city streets. I'm not saying this to say these aren't things we should be doing. Of course we need to look to densify our cities. But in terms of the question of resilience, we've got to be careful that our structures are designed in such a way that we create systems that themselves are resilient to change. And what we know about our climate is it is going to change. It's going to change in ways that are going to make events much more extreme and much more unpredictable. And I just merely wanted to point out the, if you like, exquisite tragedy that's developing of dealing with these conflicts at the same time as we've got this huge weight of development that we have to deal with. So there are some very big problems that are going to need some very clever minds to resolve over the years into the future. And certainly one of the things that I'm wrestling in my role as Planning Minister is to deal with planning challenges in the present in such a way as not to create headaches in 40, 50 years' time for future governments and societies to have to resolve. One of the ways in which I believe that it's important that we can start to wrestle with these sorts of ideas is by obviously sharing with the experience of other cities. That's why I took the step as Environment Minister, as I was before the election, of joining up with the Climate Group, which is a group of international, of sub-national governments and city governments at an international level, which gets together to discuss fundamentally what the role of sub-national jurisdictions is in relation to climate change, and that is issues of adaptation. Across the world, sub-national governments are generally those that are most directly involved with land use planning, and so adaptation rather than mitigation is something that is very, very much within our bailiwick. And so we have the capacity to learn from some of the great case studies around the world of how to deal with these sorts of issues in other global cities. One of the things that certainly the Office of Environment and Heritage, which is part of the Department of Planning and Environment, the New South Wales Government has been doing, is been partnering with local government through building resilience grant opportunities. To give you one example, there was a grant recently given to the Broken Hill City Council to look specifically at how the built form in a regional city that under climate projections is going to face an extra 40 very hot days per year, to the extent that the west and northwest of the state is going to see about a third of the year over 35 degrees by 2070. They're obviously going to have real pressures in terms of developing building stock that is able to withstand those sorts of pressures and be comfortable for habitation. So in terms of partnering directly with local councils to come up with design guidelines and criteria that are suitable for different districts. Because one of the things that is very clear in relation to climate modelling is it's not, while you can make grand statements at a very general level, it's very clear that impacts are going to be quite local, and it's important that we are flexible enough to relate to those local impacts. The other interesting pilot that we're working on at the moment is in relation to the urban heat island effect, which there was an interesting article just in this week's, I think it was Sydney Morning Herald, this weekend's Sydney Morning Herald, about the urban heat island effect and its effect within the town centre of Penrith. Penrith is one of the identified regional centres in Sydney's growth plans, a plan for growing Sydney. But what this research has told us is that the town centre of Penrith is significantly hotter than areas to the north in Londonderry or to the south in Mulgoa, which have a greater tree cover and vegetation cover. So one of the ways in which we can deal with the urban heat island effect is being dealt with through a Cool Roads project, which is being run by Michael Mobbs, who might be familiar to many of you out there. And this is a project which we're taking an inner city precinct around Newtown and putting in lighter coloured roads and seeing what the impact of having lighter coloured roads is in terms of reflectivity and actually reducing the urban heat island effect, as well as putting in street trees to try and cool down that precinct, and seeing what impacts that has in relation to energy use in surrounding structures, and what the benefits are at a very local scale of actually seeking to cool down our road surfaces, remembering that transportation takes up about 30% of the land area of the city. Related to that is a project that I'm very keen about, which is the Sydney Green Grid project. This has been really the result of some great work that's been done by the New South Wales Government architect, and it's looking at all the bits of land that are left over. The riparian corridors, the bits in public ownership that no one's quite got round to figuring out what to do with, and urban parks, and the way in which this drainage easements, the way in which this grid of public or otherwise unused land might be usefully reimagined as a grid to articulate communities, to differentiate from developed places, and also to serve as a cool sink, if you will, to deal with the consequences of the heat island effect. And that is being funded through green space grants through the Department of Planning and Environment. Finally, I just wanted to refer to the coastal reforms. Obviously, one of the key impacts in relation to climate security is the impacts of rising sea levels and greater storm activity on our coastline. That's something that we're dealing with through coastal reforms, effectively working with local councils to find out what the impacts are, embayment by embayment, of rises in sea level, and how that needs to be factored into decisions about development. I'm getting the wind up, but I'm very passionate about this, so I could happily talk for hours. But thank you.
Thank you, Rob Stokes, and thank you to the panel as a whole for such interesting and diverse presentations. And I would like to open the floor to any questions the audience might like to ask the panelists as a whole or individual presenter.
Thank you. I'm never stuck for a question. Chris McIntosh, and I'm a ridge dweller from Thornley, which might be a good scenario, might not. My question is probably to Jenny and maybe to Andy, but it's this dialectic I have between climate change versus weather change and weather impacts. In one scenario, you might say, well, yes, we've got climate change, and maybe we can grow bananas in Sydney instead of the normal cut-off, which was Port Macquarie. That is, are we going to become more subtropical as it warms, and so we'll have higher rain, high humidity, but maybe not with greater fire danger? Or are we going to have a bit of both? That is, we've got climate change, meaning the east coast of Australia might have the southern migration of subtropical climate coming into temperate, but it's going to be punctuated by more extreme weather events. And it's that flip-flop that I wrestle with.
So the answer is all and more. So I don't like... So there are people who describe climate change by it'll be like it currently is 100 kilometres north. You know, we'll just see a gentle shift of the climate southward. I don't think that's what we're going to look at all. We're completely changing the gradient between the ocean and the land. We're changing the temperature gradients across the land from the coast to further inland. We're changing the dynamics of the way the ocean couples with the atmosphere. We're changing the way that the ocean currents move energy in and around the ocean circulations. So we're looking at profound changes in the basic baseline physics of the climate. And what that will translate to, in a broad sense, is the kind of results I talked about from NARCLIM and the Minister mentioned in his speech. But the detail, the actual detail of what it will look like, remains beyond our capability, hence the value of resilience in our planning systems that the Minister talked to. So I don't like an analogy approach. I think it's just going to be different, hotter, more extremes, and that is going to test our capability to cope with it.
From my point of view, the way that we can deal with these possibilities, we don't have certainty around climate change on the very local scale, is for local government to be as flexible and adaptable as it can be in its policies. And what has been written into our climate change adaptation policy is virtually a continual review of the science and a modification of the policy as the science better informs us.
Thank you. My name is Rupashi, and I guess I have this question open to the entire forum. When we talk about climate change, we usually discuss local governments and local businesses as the most important players in adapting to climate change. Whereas the only prescriptions that you have for a regular citizen is, use less air conditioning or sustainable do-it-yourself projects. But realistically speaking, how can civil society help in adapting an entire structure that is essentially adversely responding to climate change? How can we participate in developing a structure that is moving in a positive way?
I'd love to have a go at starting off. One of my favourite tomes is by a bloke called John Ralston Saul, who talks about the unconscious civilization, and effectively he's saying that we fail to make choices. We basically get marketed at, and we do what we're told to do. So I think the answer is we do need a stronger discourse about these sorts of things. We do need more people to act consciously. So whether that's in relation to energy use, whether that's in relation to consumption patterns. I mean, as Planning Minister, I have to respond to the fact that we have a society that wants bigger and bigger homes. And it seems to me, there was a fellow called Arthur Morris who started the arts and crafts movement in Britain at the turn of the last century. And he said there are two questions when making any purchase or any acquisition. He said, ask, is it beautiful and is it useful? Now, I think today we ask two questions as well. We say, is it big, is it cheap? We need to start asking the right questions as a society and being conscious, because in one sense, decisions by government, we merely and appropriately, as a democratic society, reflect the society that elects us. And so society needs to be more involved in these debates.
Just touching on what Rob was saying, it's think of yourself as having your own supply chain. Okay, I talked about Fuji Xerox impacting natural capital. You do as well as a consumer. So it's not just about your direct energy use, it's about everything you buy, the clothes you wear, the food you buy, the car you drive. That all has a supply chain. As a consumer, you vote when you buy. Okay, so when you spend your money, you're voting for the system that supports the product that you just bought. So what we're trying to do is actually deliver a product that's more sustainable. So when people use us, they're voting for our product, they're more sustainable. It's up to you as a consumer to make that decision when you go to buy. How do I know this is this hasn't been produced in poor labour standards overseas? How do I know that this isn't an energy intensive? Those externalities which I referred to, natural capital, how do I know that the true cost of this product doesn't basically exceed the fact that I'm paying a discounted price at the retail outlet? So yeah, that's a responsibility as a consumer, and of course there's a producer responsibility as well.
Thank you. I just wanted to say thank you very much for Fuji for actually coming here and being 100% honest. It's not very often you hear big business actually saying, we pollute, we do this, we do the other. I've got a lot of questions. I'll email them to the Minister if he promises to answer them. Professor Pittman, we see Yemen is starting to go on par in terms of dramatic weather and drying out. They are down to Australia. They are down to 100 metres or so for tapping the underground aquifers and water to take, autocorrector's changing my words. They're accelerating and they will overtake us and become the first country to become completely dry. What does the data state for Australia? How long before it will become, if we don't do anything, how long will it become the Sunberg country if we keep using city planning ideas of tapping bore water and tapping aquifers instead of utilising what was stated 100 years ago to utilise more wetlands and more natural water resources? If that made sense.
I don't know. It depends where you are, it depends on the nature of the aquifer, it depends on how fast it's tapped, it depends on whether it's one of the aquifers that was recharged by East Coast lows or whether it's one of the ancient aquifers that was filled at the end of the last ice age. It just depends. But efficient use of water has to be a good idea. And I know there's a lot of investment, I think state and federally, in optimising use of water. And that has to be a good idea. That's good planning. It's good resource management. I think an awful lot of the ways that we deal with climate change can be addressed by good planning, and it's rare that I find somebody who's got a tougher sell than a climate scientist, but the minister clearly has a tougher job in dealing with some of the issues. I'm stunned by that population figure that you gave us. Oh well, house prices should not stabilise in the near future. So I think it's about planning and it's about efficient resource use, but I think that's a good thing to be doing for an economy, for the environment in any case. So I'm not sure it's kind of rocket science, but when Australia will dry out?
Hi, my name's Alex, and I got a question for Rob Stokes, as Planning Minister. There's currently a bill before the Senate which looks like it's going to be making a number of changes to the, I guess, the objector appeal and merits appeal processes to large state significant projects. Like the Warkworth coal mine and things that are going to have a significant impact on climate change in Australia's future. So as Planning Minister, how do you plan to address the impacts, especially indirect impacts related to emissions, when giving approval or looking at approval for these kind of projects?
Well, certainly the factors the decision makers are required to take into account are those outlined in the Environmental Planning and Assessment Act. I have spoken quite strongly about the need to ensure that we do not walk away from the concept of ecologically sustainable development. In fact, I think we need to consider ways in which we can effectively operationalise it. It sits in legislation as an objective, but it's not very clear from that legislation when applied by decision makers, whether they be delegated decision makers in the specified instances where the minister is still a decision maker, or where that decision maker is the court. It's not very clear from the legislation as to what that actually means in an operational sense. There are plenty of things that we do and plenty of activities of development that are inherently unsustainable, yet we haven't figured out better ways yet of meeting social and economic needs in ways that are also environmentally sustainable. So at this stage it sits out as a goal, as an objective that we are aiming towards. My ambition is to work to ways in which in future legislation we can seek to operationalise ESD and actually put some definitions under it as to what it means. But having said that, it'll clearly still be a balance, and that balance will depend from project to project, and it will be a bit of an uncertain science, because it will depend on a huge range of factors, and the fact that we are getting better at reporting on things like likely environmental impacts doesn't actually make the job of decision makers easier. It makes it more difficult, because then you've got to assess more factors. There are more variables in decision making. So I don't have a clear answer, but it needs to be an objective as a society we're aiming towards.
Tim, really excited about what Fuji Xerox is doing, and I think that's amazing how it's just not carbon neutral but resource neutral as well. Just wondering, into the future, we're kind of looking at symptoms, not the causes, and causes is big business creating sort of world-destroying products. Just wondering how in the future can we regulate against that and make sure other companies can take that more resource neutral ideology.
No, good question. And yes, big business does have a huge responsibility for what we're seeing today in the science. It also has the opportunity to probably affect it the most and change the fastest if the will is there within the business, and if the will is there within the stakeholders that are talking to that business. So what I talked about before was natural capital. That needs to be factored into the decision making of the business. At the moment, it sits external to their profit and loss statement. It sits external to the formal economy. That actually needs to be brought in to the decision making process. It needs to be given value, and this is not an easy thing to do at all, by any means, but you need to actually give a value to that which you're extracting and also you're polluting towards. You know, the carbon tax was a perfect example of where a value was placed on carbon emissions for a period of time. That's probably going to happen more and more as resources become more and more scarce and their availability means their price goes up. So it's actually factoring in the triple bottom line considerations, be they natural capital and social capital. We haven't talked about that tonight, but people, they're pretty important as well, into the decision-making process of businesses. And we're seeing that change, actually, at the moment. I'm seeing that change within some leading businesses.
Could you please join me? Another warm round of applause for our panelists.